the weather is just way too nice to stay inside. So I had to go outside and enjoy some outdoor activities, like a little bit of soccer. Go! Oh, wait. Quiet down. Now it's time for some golf. Want to be greenside. Mr. Maz, eyes up his shot. Just 20 yards from the green. Let's see his approach shot. Fantastic. Look at that touch around the greens. Oh, time for some football. He's got a man wide open in the end zone. Touchdown! A little bit of basketball. So now the obvious question, what does all this have to do with math, or specifically algebra? And if you think about what did all of these have in common? Projectiles. The soccer ball, it went into the air and came down due to gravity. The golf ball started on the ground, flew up in the air and came down. The football flew up in the air. The basketball. So everything was a projectile and had a certain trajectory. All right, and it's not just sports. Anything that is flying through the air is a projectile, and you can map a mathematical equation and use math to figure out how do you keep it in flight, how long is it going to be in flight, what's its highest point, its lowest point, what do we need to do to make sure it doesn't come crashing down to the ground like an airplane or a rocket ship. So this is kind of our introduction to quadratic functions, all right, and something called a parabola, spelled parabola, but we pronounce it parabola, and it gives us a nice symmetrical arc. So let's take a look at parabolas, which come from quadratics. So I did a quick Google search of some parabolas, and I found this image from Lumen Learning, which I like because it showed an example of a minimum and a maximum for the parabolas. So these curves right here, these are what we are referring to with parabolas. And what's kind of nice about this is they give us the equations. And we're going to look at different types of quadratic equations here. But these match these particular parabolas. One thing that I'm going to point out right away is notice that there is a squared. And this would eventually give us an x squared. But when the variable x is squared, that's how you know you're going to get some kind of parabola. And you'll notice for this one, there is a negative sign here. That's what flips it so it's upside down. This is actually the type that we would use for the projectiles that we were talking about. When you have a positive x squared value, you get a curve that looks like this that opens up. All right. So some major things to note about parabolas. There is a point right here. So this vertex and this vertex, if it's a positive x squared and it opens up, this is going to be called the minimum because it is the absolute lowest point that this parabola goes. Now it's going to extend forever and ever and ever in the positive direction going upward, but this is the absolute lowest. So this vertex is called a minimum. This vertex is called a maximum because it is the absolute highest that it can go. So when you're talking about a projectile, it's the highest point in the air that the projectile will travel. Another thing that I want to notice is the symmetry. All right. If you put a line right here, they call this the axis of symmetry. So everything is the same to the left and the right of that. If I go up right here, you'll notice that this is 2 to the left from that axis of symmetry, and this point is 2 to the right. And if I were to go up here, this would be 3 to the right of the axis of symmetry. This would be 3 to the left. Let me try to draw an axis of symmetry real quick. I don't know if it's going to let me. That's not bad right there. All right, so now it might make it a little bit easier for us to see what's going on here. So here's our axis of symmetry. This point here, 1 unit to the left. This is 1 unit to the right of the axis of symmetry. Right here, we're 2 units to the left and then 2 units. So you see that perfect symmetry with a parabola. And that's always going to be true, which kind of makes them nice to graph. I could have the vertex, and I could find this point, and if I know this point, I automatically can get that point. And if I figure out what this point is, I automatically know this point because of the axis of symmetry. So those are some things that we're going to look at in depth. We're going to keep it to the basics here for the beginning. So let me show you a few of those things. We're going to be looking at 3 different types of problems for this assignment on ALEKS for Intro to Parabolas. So as you can see, we have a parabola here, one that has a minimum value because everything is higher than that. And the first type of question is going to ask, does it open up or does it open down? And we discussed this a little bit earlier when talking about parabolas. So you just look for the opening. All right, this is the opening part right up here. That's the big open area. So that is to the upper part of this. So we'd say this opens upward. If it opened downward, the parabola would look something like this. Taking a look at B, find the equation of the axis of symmetry. So we talked about how they were symmetrical. So if we just kind of drew a line, all right, that would kind of be the axis of symmetry. And this is actually going to go hand in hand with the vertex down here. Find the coordinates of the vertex. So the vertex is either the minimum or the maximum. At this point, the minimum. So we're looking at this point right here, which is -2, -4. And the axis of symmetry is always a vertical line that runs right through that vertex. And remember, a vertical line always has an equation of x equals some kind of number. So along this vertical line, x is always -2. So when it says the equation of the axis of symmetry, make sure that you have x equals whatever the x value is for that vertex. So that's why kind of B and D are going to go in hand here. X and Y intercepts, we've talked about these plenty of times. X-intercept is where does it cross the x-axis. So obviously here is our x-axis, and when we look at this, where does it cross the x-axis? At -6 and excuse me, at -6 and at +2. All right, and it says separate them with commas if there's more than one. The y-intercept is where it crosses the y-axis, and this occurs at -3. Now, with parabolas, there is only ever going to be one y-intercept, or maybe none. That's a possibility, because parabolas are always going to either open up or open down, and with the y-axis, it's only ever going to cross it once. All right. The x-intercept, there could be 2, there could be none. If I have a coordinate plane, it's possible that my parabola is like this. And if it opens up, then there's a minimum point right here. That's never going to get to the x-axis, obviously. So it is possible that there are no x-intercepts. And I think I just misspoke. There will always be one y-intercept. Because these are going to continue on forever and ever and ever, either going in this direction or going in the downward direction, and they will always get to the y-axis at some point. The next problem we're going to get into is actually graphing parabolas. Before we do this, we're going to ignore the actual problem that we're talking about, and I want to just talk about y equals x squared for a second. This is called the parent function. All the other ones are like the little kids. So this is the parent function. I want to talk about what this looks like. And what I want to mention first of all is when they're talking about graphing this, it says plot 5 points. One of them has to be the vertex, and then 2 points to the left and 2 points to the right. In the parent function, and actually the types of graphs that we're going to be looking at today, the vertex is always, always, always when x equals 0. So then all we have to do is, okay, if y equals x squared, just figure out what 0 squared is, which is also 0. So that's going to be at 0, 0. So that's one of the points that we need. And then 2 to the left of that could be when x equals -1 and when x is -2. And then 2 points to the right are when x is 1 and when x is 2. And remember the symmetry. If we figure out when x equals 1, we automatically know what the y is going to be when x equals -1. And same thing with 2 and -2. So I think it's much easier to just work with the positives. So when we do x equals 1, we just got to figure out what 1 squared is, and that's 1. So we automatically know y is 1 when x is -1. And 2 squared is 4, so we automatically know that -2 squared is 4. And just a point about that real quick. Remember, this is x squared, and some people think, oh, -2 times -2 is obviously +4, but if you put that into your calculator, if you put -2 squared into your calculator, it's going to give you -4. So you have to be really, really careful about that. What you really need to do is put -2 in parentheses squared, and then it will give you +4, which would be correct. All right, so just talking about the points here that we would be graphing, I'm going to go ahead and grab the points, and I have these memorized in my head. So we have 0, 0, we're going to put down there. We have 1, 1, and we have 2, 4. And then we know that the axis of symmetry looks like that. And then they have a really cool parabola point, or parabola grapher. So remember, this was y equals x squared, not y equals 3x squared. This is the parent function. All right. Now, what's going to happen here when we actually get to y equals 3x squared, it's going to keep the vertex in the same spot. Whenever you multiply the x squared value, it's going to stretch out the graph. So if you think about it, 1 squared is 1, but if I multiply 1 by 3, that's going to make this graph a lot skinnier. So I'm going to go ahead and delete all of this stuff. Actually, let's just redo everything. All right, now let's get into this actual problem. Bring up, whoops, my tool again. Okay. So I have my x and my y. I know 0 is still going to be, if I just follow order of operations, 0 squared is 0, 3 times 0 is 0. So my point is still 0, 0 here. I missed. I'm going to be right at the origin. Just pretend that's right at the origin. It's very difficult to be precise with this. And then I'm going to go ahead and do 1 squared and 2 squared, but multiplied by 3, remember. So order of operations, do the exponent first. 1 squared is 1, times 3 gives me 3. 3 times 2 squared is 4, times 3 is 12. So I have 0, 3, and 12 for my y values. And I'm also, when I get -1, I'm going to have 3, and -2, I will have 12 as well because of that symmetry. So you don't have to do the math once. And I want to show you another tool real quick. So we got to remember 3 and 12 because this does not save. We have this tool as well, which is, it plots the points for you. So if I put 0, 0 in and hit plot point, it will automatically plot that for me. And when I put 1, 3 in, it will plot that point for me. If I put -1, 3 in. So if you're ever having trouble getting the precise points plotted, or you come up with a decimal, that tool is very useful as well. So just like the directions say, I have 5 plots pointed. One of them is the vertex at 0, 0. I got 2 to the left and 2 to the right. I use my parabola tool and it graphs it for us. Okay. I want to see if I can find one where it has a negative x value here. Here, perfect. Right on cue. All right. So this is very, very similar. You can kind of imagine, or we've talked about this before, what the negative x squared does, in this case negative 2x squared, it just flips it so it opens downward instead of upward. So to bring up my marker again, and we can probably do a lot of this in our heads, but I'm going to write it down anyway. So 0, 0 is still going to be the vertex. There's nothing else going on here. So we still have 0, 0. 0 times 0 is 0 times negative 2 is 0. So we've got that. And then I'm going to go with 1 again. All right, so negative 2 times 1 squared, exponent first. 1 squared is 1 times negative 2 is negative 2. When I put 2 in there, negative 2 times 2 squared, we got 4 times negative 2 is negative 8. And then once again, if we knew 1 is negative 2, negative 1 goes with negative 2. And also negative 2 is going to go with negative 8. So we've got 0, 0, 1, negative 2, and negative 8. So let's go ahead and plot those real quick. So 0, 0, 1 gives me negative 2, and so does negative 1. And then 2 brings us down to negative 8. And negative 8. So this is what this parabola will end up looking like. So that's another type of problem. Let's go towards the end here and get the third type of problem. All right, so you see we've got an x squared again, but then it says minus 4. And all of this minus 4 does is it's going to shift this graph up or down. All right, in this case, it's going to shift it down 4 units. All right, if it happened to be, say, x squared plus 7, that plus 7 is going to shift it up 7. All right, and you can figure this out with the math, obviously. All right, but if you remember, I'm going to kind of do an x squared versus an x squared minus 4 here. So if I have my xy chart, we kind of did this one before already. We'd have 0, 0. We would have 1, 1, 2, 4. And I know this might not make this might not be the best order. A lot of people will go with negative 2, negative 1, 0, 1, 2 to put all the x's in order. I like to stick with the positives first and then use the symmetry to be my guide here. But I just want to compare this real quick. If I know 0, 0 works, then all I have to do, like I have the x squared, then I subtract 4 from everything. 0 minus 4 is negative 4. 1 minus 4 is negative 3. 2 minus 4, or sorry, 4 minus 4 is 0. And then we have the same points, negative 3 and 0. So it just really takes this graph and just shifts the whole thing down 4 units. So typically, I would be at 0, 0, but I'm going to go down negative 4. And then I would be at 1, 1, but I'm going to go down 4 spots. 1, 2, 3, 4 at negative 3. And then the next one would be at 4, but that goes down 4 spots. And then I go ahead and use my symmetry. And there's a graph. There may also, let me see if I can get another one here. No, I think they're all going to be that way. Okay. I was just wondering if Alex is going to give you anything that isn't x squared. So in this case, we start with the x squared at 0, 0. We go down 3 spots. We start at it would be 1, 1. Go down 1, 2, 3 spots there. Got our symmetry. 2, 4. Go down 2, 4, 1, 2, 3, be there. And there's our symmetry, and there's the graph. So your assignment for the early part of the week, Monday, Tuesday, May 4th, and May 5th, for those Star Wars fans out there, may the 4th be with you. But the assignment is called Intro to Parabolas. It's on alex.com. There are 10 questions. Like I said, 3 types of questions. 1, identifying the vertex, does it open up or down? The next one is graphing x squared with a factor, and then x squared plus or minus something, shifting that graph up and down. Good luck. I will always be available on Zoom during class times or office hours when you need help.